you look at the gray graph, this is this one here. Again, I can write that as 4 to the x minus 2. So then my x minus p, my p is equal to minus 2. So the gray graph is 4 to the x shifted 2 units to the left. Or I can say that 4 to the x plus 2 is the same as 4 to the x times 4 to the 2. That is equals 16 times 4 to the x, like that. And then it means that this 4 to the x is stretched vertically with a factor of 16. My domain is R, but my range is again from 0 to infinity. My y-intercept, that happens at 4 to the 0 plus 2, which is equal to 16. And no vertical asymptote, but my horizontal asymptote is again the x-axis. It's actually quite boring, but that is how it is. Here we have our 4 to the x, and here we have y equal to 4 to the x plus 2. So you can again see that from there we have shifted 2 units to the left. From there it's 2 units to the left. And from there it's 2 units to the left. But I can also see that if I look at this point here, if I put minus 1 in 4 to the negative 1 is a quarter. And 16 times a quarter gives me 4. And this is this f value of mine. So here's my 16 times a quarter. In other words, if I measure from the x-axis to A, I will get a quarter, but if I measure from the x-axis to F, I will get 4 units, which is 16 times a quarter. The same will happen at other values, but we cannot see it on the graph. So if I look at B, which is 1, then 16 times B will be at 16 on the y-axis, but it's not on our graph. If you can do the horizontal shifts, it's much easier than the stretches and the shrinking of the graph. So try what is easier for you, depending on whether you can or not.